Dear Texans and non-Texans, I hope you all enjoy yourselves as much as Robinson, Schild and I did 50 years ago as we invented the Texas Symposium on Relativistic Astrophysics. It was then a free for you all, with free booze and few leisurely talks, no registration fees, no parallel sessions. My work in cosmology began in 1952 when I became a student of Pascual Jordan, one of the Quantum 10 who created quantum mechanics and field theory in the 1920s. Dirac had suggested in 1937 that the ratio of gravitational to electromagnetic interaction in the hydrogen atom should lessen inversely proportional to the age of the universe. Jordan elevated this numerological idea to a scalar tensor theory of gravitation, with the scalar as a dying gravitational coupling. He had written a book about it and asked me to solve the formidable equations for models of the universe in his theory. Since Pauli was also interested in scalar tensor theory, Jordan had asked his publisher to send Pauli a complimentary copy. I learned later there had been a problem. All pages were blank in the complimentary copy, and Pauli had remarked to Markus Fürst, "Jordan knows that I could think what should be in it myself." Together with Jürgen Ehlers, Wolfgang Kund and Manfred Trümper, we founded the Hamburg Relativity Seminar to study Einstein's theory of gravitation, and I began to work for Otto Heckmann, director of the Hamburg Observatory. Heckmann had written a book on cosmology and wanted me to help him produce a new edition. This did not happen. Instead, we published handbook articles reviewing cosmology, and I wrote papers with him on Newtonian cosmology and anisotropic or rotating models of the universe. It was in 1955 that my interest in the physical aspects of cosmology was sparked. I had my office in the building that housed the 32-inch Schmidt-Spiegel of the Hamburg Observatory, and Walter Bade had come from Pasadena, California, to celebrate the inauguration of the telescope. Bade was then the greatest observational astronomer of his time. He was absolutely fascinated by his research, gesticulating, incessantly smoking, with carefully parted thin white hair, with somewhat bushy eyebrows and protruding hawk nose. He saw the mysteries of the universe as the greatest of all detective stories in which he was the principal sleuth. Sparkling with ideas, confident of the latest numbers and results, he told me the story of the cosmic radio source Cygnus A, the brightest in the sky. Bade said in 1951 at a seminar talk that Minkowski gave in Pasadena on the theories of radio sources, I got mad. I had just published the theory of colliding galaxies in clusters and identified the Cygnus A source with such a pair in collision. Nobody would believe that there were extragalactic radio sources. Minkowski reviewed all the other theories first, and then, at the end of the seminar, as if he were lifting a hideous bark with a pair of pincers, he presented my theory. He said something like, "We all know the situation, people make a theory, and then astonishingly they find the evidence for it. Bade and Spitzer invented the collision theory, and now Bade finds the evidence for it in Cygnus A." Bade said, I was angry, and I said to him, I bet $1,000 that Cygnus A is a collision. Minkowski said he could not afford that. He had just bought a house. Then I suggested a case of whiskey, but he would not agree to that either. We finally settled for a bottle and agreed for the evidence for collision: emission lines of high excitation. I forgot the whole thing until several months later Minkowski walked into my office and asked, which brand? He showed me the spectrum of Cygnus A. It had neon 5 in emission and 3727 and many other emission lines. I said to Minkowski, I would like a bottle of Hudson's Bay Best Procurable. That is the strong stuff that the fur hunters drink in Labrador. But that was not everything. For me, a bottle is a quart, but that Minkowski brought was a hip flask. I did not drink it. I took the flask home as a trophy. But that's not the end of the story. 2 days later, it was a Monday, Minkowski visited me in order to show me something. He saw the bottle and emptied it. Isn't it a shame that you get no returns when the horse is the horse you bet on? Is it that sure thing? Bade's collision theory did not hold up when the source structure of Cygnus A emerged under higher resolution. But he had been right in putting this source into deep space, more than 500 million light years away. He had discovered that radio galaxies were new probes of the universe. Walter Bade retired in 1958 and died in 1960. His successor at the Carnegie Observatories became the Caltech astronomer Martin Schmidt. The spectrum of Cygnus A that Minkowski took with the 100-inch showed a redshift of 5.6%. In 1960, on the last run with the 200-inch before his retirement, Rudolf Minkowski took the spectrum of the radio galaxy 3C295. He recognized a faint trace of a single line that he figured to be the shifted O2 line 3727 with a redshift of 46%, the most distant measured landmark in the universe till the Second Texas Symposium in 1964. At the 1958 meeting on radio astronomy in Paris, France, it became clear that the radio galaxies were among the most distant objects in the universe. But also another of their properties came into focus. Bade had observed polarization in the visible light from the Crab Nebula and the jet of the radio galaxy Virgo A that turned out to be synchrotron radiation of highly relativistic electrons, according to Ginzburg and Shklovsky. As Jeff Burbidge stressed in Paris, this led to energy estimates of 10 to the 60 ergs for large radio galaxies. In 1961, I visited the US on a fellowship. Most of the time I spent in Syracuse with Peter Bergman and his co-workers. But I also had occasion to meet some cosmologists. It started at the first stop in England. The oldest test of cosmology, going back to Halley, plots log n versus log I. Here n is the number of sources up to a certain intensity I in some fixed area on the sky, and for constant density n should grow with the third power of the distance. On the other hand, the intensity I should diminish with the inverse square of the distance, provided there was no absorption and all sources were alike. That means a log n log I plot should give a slope of minus 1.5 in Euclid's space, since the steady-state universe of Bondi, Gould and Hoyle sported a Euclidean space and constant density, its log n log I test should give a slope of -3/2. The radio astronomer Martin Ryle, director of the Mullard Observatory in Cambridge, England, counted radio sources to test the steady-state theory. The sources of his C2 catalogue gave a slope of -3, but steady-state cosmology survived because many of the C2 sources did not exist and were phantoms of confusion. Another error had also shaken trust in Ryle's modus operandi when in 1957 he had predicted the demise of the first artificial Earth satellite. Ryle, who had worked in radar during World War II, had tracked Sputnik and announced to the world press that it was losing height. But the flying radio kept up. Asked at a meeting of the Royal Society about the error, Ryle admitted, "We assumed the Earth was flat." The meeting of the Royal Society at Burlington House in London on February 10, 1961 should decide whether Ryle or his Cambridge colleague Hoyle was right. My friend Felix Pirani had taken me along to the session. Outside of the 4 p.m. meeting, newspapers had already condensed the result into the banner headline, "Universe, Bible is correct." Inside, Ryle, in a dark suit with brown shoes, explained with British upper-class accent, his father was a king's physician, the wonders of his 4C catalogue. The slope was -1.8, and the final sentence I quote was, "No attempt has been made to explain the observations in terms of an evolutionary model, but it is now difficult to accept a steady-state model as representing the actual universe." Fred Hoyle did not show up. Apparently he knew the result and had sent his graduate student, Yayan Narlika, to put up a weak defense. Hermann Bondi, as secretary, offered also some critique, but Martin Ryle had made good. Like most astronomers, I didn't believe in Hoyle's creation field of negative energy. It was in July 1961, in Princeton, that I met Kurt Gödel. In 1949 he had discovered the model of a rotating universe with bizarre properties for time travel. He published it in a Festschrift for Einstein's 70th birthday, followed by further results about rotating worlds without proof. Up to that time I had worked at the Hamburg Observatory on similar problems, and I wanted to learn how Gödel had achieved his results. I phoned him, and he asked me to see him at his office at the Institute for Advanced Study at 2 p.m. the next day. It was a hot day in New Jersey, and I had been early for the appointment when I saw a taxi pull up and a person emerged from it in a winter coat, a scarf around his face, and a grey hat pulled over his forehead. This person turned out to be Kurt Gödel. His office looked as if it had not been used in months. There was a huge pile of neatly stapled, unopened mail on an otherwise empty desk. Gödel pulled out a filing cabinet of considerable depth and showed me his calculations. He had done the 9 different Lie groups separately, as I had. There was no royal road to the results. That was good to know. I asked when he would publish his work. Not in the next 10 years, was his answer. He never did. He starved himself to death. The father of Genesis in modern cosmology was Georges Lemaitre. He described the remarkable concept in the book The Primeval Atom, an essay in cosmogony. The development of the world could be compared with the end of fireworks. Some red wisps of smoke and ashes, we stand on a well-cooled cinder and see the slow vanishing of suns and try to remember the past glamour of the world's beginning. I met Lemaitre when he was visiting professor in Berkeley's astronomy department. He was an amiable man with a stout build under the black cassock. He proudly told me that he had just united the West Coast astronomers Erika Vitense and Carl Böhm in holy matrimony as a useful in-house function for the astronomy department. The Heckmans had offered to drive Lemaitre and me to Mount Palomar and then to a conference on clusters of galaxies at Santa Barbara. Heckman drove through the Sajquin Valley, with Lemaitre to his right, with Mrs. Heckman and me in the back. Lemaitre, in his black habit, with clerical's collar, told us how he had bought his black shirt in London, in a London store, specialized to the outfitting of fascists. Then he returned to reading his breviary, perhaps a reaction to Heckman's Autobahn driving. It was already dark when we stopped at a motel near Escondido at the edge of the Palomar Mountain State Park. The Heckmans went to bed early, but Lemaitre and I relaxed in deck chairs by the swimming pool. When I told him about rotating world models, he said, "Ah, you give l'atome primitive a spin." At the 1927 Solvay conference, he had shown Einstein his expanding universe, who had reacted, saying, "Your calculations are correct, but your physical insight is abominable." Apparently, Einstein was then still believing in a static universe. The next day, we were to meet Alan Sandage to show us the 200-inch. Alan was exactly 1 hour late. He was still on standard time. The newspapers reported on this day that the second cosmonaut was circling the planet as a new satellite. Sandage, Lemaitre and Heckman saw no need to lose a word about it. On the way to Santa Barbara, we stopped at the Athenaeum in Pasadena. While being a postdoc at Mount Wilson in 1925, Lemaitre had sat for a portrait that was supposed to be hung in the Athenaeum. No luck. I met Alan Sandage again at his office at 813 Santa Barbara Street in Pasadena. He had just published his paper, "The Ability of the 200-inch Telescope to Discriminate Between Selected World Models." It reduced observational cosmology to the search for the two numbers h0 and q0 from the redshift distance relation for vanishing lambda. I told him I liked the program, except that he should fix the attached tables for galaxy counts that he had calculated with the wrong branch of the arc sign. He showed me the spectrum of the then most distant galaxy he had taken with the spectrograph of the 200-inch. It was not larger than my thumbnail. Between a double set of always equal fat and thin black lines was a tiny black smudge, in the middle a bit thicker than at the end. He gave me his loupe, and when I looked more closely, it seemed as if the smudge on the right end was briefly interrupted twice. I held the tiny piece of film against the light. "That is Hydra," said Alan. "You see H and K. The velocity is 60,000 kilometers per second. I have just calculated how long I have to keep this spectrum till I can take a second one to be able to measure a change in the velocity. It's millions of years." The Santa Barbara meeting of the International Astronomical Union on clusters of galaxies was run by the British Secretary of the American Astronomical Society, George McVitie, a vociferous enemy of the steady-state theory. Heckman, as vice president of the IAU, was responsible for the program. Zwicky had insisted that he should give 6 major talks at this conference. When he was cut down to 1, he wrote to the Hamburg authorities that they should fire Heckman for incompetence. The one major address by Zwicky of how to count the galaxies in a cluster ended on an unusual note. George Abel, who had made a catalogue of galaxy clusters from the Palomar sky charts, asked Zwicky to explain a point and was rebuffed by, "See my patent, lawyer." At the closing of the conference, McVitie's final words were interrupted when Tommy Gold shouted, "McVitie, you are a liar!" On this unhappy note ended the meeting, remarkable for the scarcity of memorable results. Most of the attendees continued to the assembly of the IAU in Berkeley. I shared a ride with Martin Schmidt, Kevin Prendergast, and the Burbages. We stopped in King City for lunch. Martin Schmidt went to the men's room and came back immediately. He said, "You have got to see that." We all went, except Margaret Burbage. Next to the urinals, the proprietor had put up a blackboard and chalk for his male customers to leave unprintable messages. We read, "The rest mass of the graviton is 10 to the minus 56 grams. Simultaneously we shouted, Zwicky was here. He had found a new, unusual form to publish his research and share his thoughts with the male part of the population. I reported about the first Texas Symposium 25 years ago here in Dallas on the 11th December 1988 at the 14th Texas Symposium. But the organizers who published the proceedings refused to print the text of my talk. You can read it in the August 1989 issue of Physics Today. Walter Sullivan's full-page piece about the symposium Stars over Dallas in the New York Times had been enthusiastic, and long reports in Physics Today and Sky and Telescope were also appreciative. Thus, when Robinson, Schild and I got together in the spring of 1964, it occurred to us to also have a symposium in Austin, Texas, where Alfred Schild and I were located. However, there was a problem with the program. John Wheeler and his group were publishing a separate volume of the proceedings, also by Chicago University Press, dealing with stellar collapse. They would try to model supernova in a workshop. New quasars were discovered with larger and larger redshifts. They were faint landmarks in the deep ocean of space, further and further away from us by the time their photons were reaching Mount Palomar. In those days, our horizon widened with a speed of 1,000,000 light years every day. The redshift of 3C48 was 37% at Dallas. Alan Sandage and Martin Ryle had now the quasar 3C9 with a redshift of 201.2%. It was as if only now had the expansion of the universe become real. But a few numbers could not fill a 5-day symposium. However, the sheer violence of the quasars would make it probable that, like the Crab Nebula, they might radiate at all frequencies, in X-rays, gamma rays, infrared and UV. Observations would involve rockets, balloons and satellites. Since quasars contained relativistic particles, they might also be sources of cosmic rays. There were no X-ray or gamma-ray satellites that could identify sources, and rockets could only briefly look. Filling a week with relativistic astrophysics, we had also to talk about future projects, like finding neutrinos from the sun, having an X-ray detector up in a rocket when the moon was about to occult the Crab Nebula, and simply define all these activities as relativistic astrophysics. I found these possibilities quite exciting and went to MIT to sign up speakers for the second Texas Symposium in Austin, December 15 to 19, 1964. When our friend Yuval Ne'eman, then staying at Caltech, heard that Alfred and I would be visiting to talk to people there, he offered to invite them and us for brunch. The new ones who had not been to the Dallas Symposium were Dick Feynman, Murray Gell-Mann and John Bacall. John and Murray said they might come after listening to our invitation, but Feynman said no. 2 years ago, at a meeting on gravitation with mostly theoretical talks, he had become bored and told me over drinks that he didn't learn anything, and that he saw the relativists as if they were worms in a bottle crawling over each other. No more relativity meetings. However, just a year ago at Cornell, he had attended Tommy Gould's conference on the nature of time. He had contributed quite actively to those metaphysical discussions, but insisted that his statements had all to be attributed to Mr. X, which was duly done in the proceedings, and his name stricken from the roster of participants. But now Feynman said it was wrong to have physics meetings where one did not discuss results of experiments and observations, but would mainly be talking about future experiments and their possible outcomes. I told him that he enjoyed calculating non-observable observational things like gravitons scattering on gravitons. Was he an elitist who did think us ordinary folks were not allowed to enjoy discussing future experiments with solar neutrinos? Feynman's view were in a minority. He didn't come to give a talk or just come incognito or not to the Austin conference. Maybe if Murray hadn't gone, he might have. Anyhow, Feynman didn't come to the second Texas symposium, but Dirac did. I had the pleasure to introduce the two leading Soviet neutrino experts, Kuzmin and Satyepin, to Dirac, who quickly felt at home in Austin and stayed long after the conference. Alfred took Dirac swimming at Barton Springs, and the university offered him a distinguished professorship, but he had to decline the offer as a member of the Soviet Academy of Sciences. This time in Austin, Martin Schmidt did talk. In Dallas, Greenstein had repeatedly talked about Schmidt's eagle eyes, as if his discovery had been the result of acute vision. In Austin, Schmidt's talk was the highlight of the symposium. His analysis of the redshift, gravitational or cosmological, was a masterpiece that has stood the test of time. Alan Sandage, who had owned Greenstein's Quasar 3348 and refused to come to Dallas, demonstrated in Austin how he would find the radio-quiet quasars that after Austin turned out to be the vast majority. One odd moment occurred at the Austin meeting when Alfred's teacher Leopold Infeld, who chaired a session, forced the stagehand to sit together with him on the dais to demonstrate his socialist feelings. The poor Texan was flabbergasted. Great mirth was created during Jeff Burbage's talk, who calculated the 10 to the 60 ergs as product of magnetic energy density times volume of the source. When Jeff, of monstrous girth, was interrupted by a call from the audience, "Will the speaker please defend his volume?" Jeff did. After Austin, in January '65, Alfred and I decided we should educate ourselves about particle physics conferences and went to Coral Gables, a campus of Miami University in Florida. The Turkish physicist Behram Kurşunoglu had organized here the second annual meeting on the physics of elementary particles, attracting worms-seeking theoreticians. Alfred, born in Istanbul, thought the ties of trade and birth with Kursu would gain us entry to the meeting. He was mistaken. Kursu, the author of a crazy theory, was loath to see Raffle like us in his illustrious set. He finally relented, issuing us with a kind of yellow star, saying "Visitor" in bold letters to be worn at all times. Alfred, who had a no-nonsense approach to life, immediately disposed of these badges. I had Corso's name first heard when Ivor told me of his attempt to involve Dirac in conversation. At the '59 Relativity Conference at Royaumont near Paris, France, Ivor Robinson found himself one morning, alone with Dirac, in the basement of the ancient cloisters. In front of them a table heaped with reprints that the attendees to the meeting had left for perusal by their colleagues. Ivor, who is fond of conversing, felt challenged by Dirac's well-known muteness. To start a dialogue, He picked up a paper from the heap by B. Kursunoglu, reporting about a nuclear test, showing it to Dirac and asking, "Would you agree that this man is the second most stupidest man at this conference?" Questions to Dirac were usually followed by a long pause. So here. But his interest seemed to be aroused, and he asked, "Who do you think is the stupidest man at this conference?" "X," said Ivor. Again a long pause, then, "I don't agree with you. Since X is still alive, I shall not reveal his identity to protect my friend Ivor from frivolous lawsuits." The Coral Gables meeting on symmetry principles at high energy had 2 talks about experimental results and 16 often unintelligible theoretical ones, like a long one by Kursu on his group LU-12. This was not the way we wanted to go in future Texas meetings. However, what impressed us was the weather, thus the idea of having the next Texas symposium in December '65 in Miami. Alastair Cameron, a Canadian nuclear astrophysicist at NASA in New York, became the organizer for this symposium. It took place in Miami Beach's monstrous Fontainebleau Hotel, side by side with meetings of the Undertakers of America and the of the Jewish Undertakers of America and the Cosmetologists of America. We had left the program and planning for the conference to Al Cameron and left planning for the conference to Al Cameron, and I remember very little about it. Alan Sandage asked me to write the cosmology part for his handbook article, but I resisted. He later wrote it himself. I listened to Arno Penzias reporting about the discovery of the background radiation and asked him whether he had seen polarization. He said no. I also remember standing in a lunch line with Eivind Wichmann, the author of the quantum volume of the Berkeley course, in front of me, explaining to his colleagues his aim in life. It was traveling around the world and bedding a local beauty in every country. Yes, this was Berkeley in the 60s. I had hoped to give a 10-minute talk about a new idea in particle physics, generalizing Yang-Mills to SU3 vector mesons with a generalized Kaluza metric. My friend Yuval Neyman, who chaired one session, turned me down. He had already granted 3 different people time and could not do it. The idea did not get lost, however. Earlier in May, at the relativity meeting in London, England, I met our friend Andre Trautmann and sketched it for him. He generalized it and put his student Richard Kerner on it. It was later found that Bryce DeWitt had set it as problem 77 in his Lesouche lectures, but through Kerner, corrected by Cho, got this idea that went back to Oscar Klein in general circulation. At some later stage, when Ivor and I began to count Texas symposia, we must have forgotten the Miami one and declared it later as a non-canonical conference because we wanted to hold meetings only every 2 years. So it became Al Cameron's Miami conference. Al Cameron also volunteered to do the next 1966 Texas meeting in New York. He was thinking big, Texas style, and secured Manhattan's biggest hotel, the New Yorker, for the symposium. He had moved to Yeshiva University and invited me as a visitor in the summer of 1966 when planning the Texas Symposium in New York. This meeting had the largest audience so far, some 800 people, I believe, and the sensational refutation of Einstein's general relativity. The Princeton experimentalist Robert Dicke claimed his measurements of solar oblateness would lead to a quadrupole moment of the Sun. This quadrupole moment would cause an additional advance of Mercury's perihelion, destroying agreement between Einstein's theory and the observed 43 seconds of arc per century. My friend Ed Spiegel, a great hydrodynamicist and expert on the Sun, raised the question whether the Sun is like a cup of tea. In this discussion with Dicke, Ed brought down the house by quoting his mother, whose comment on this problem was, "From this you make a living?" Dicke did not convince me. The papers had a feast. A month later, at the APS meeting in New York, Melvin at a temple in Philadelphia ran a mini-conference with Dicke, Gell-Mann and me as speakers. I pointed out that Dicke's solar oblateness measurements had not taken into account that the faculae, bright spots on the solar face, visible near its limb, were concentrated in the Sun's equatorial zone and would bring about an oblateness profile. I talked from experience. From age 13 to 16, I had observed the Sun on every clear day and counted sunspots for the worldwide Zurich statistics. I knew that faculae are usually seen higher in the solar atmosphere near sunspots that show the butterfly phenomenon restricted to the Sun's equatorial zone. Dicke simply denied this fact. A shouting match developed. Faculae are not. I wondered whether this famous experimentalist had ever looked himself directly at the Sun through a filter or at the projected image of it. At the 1972 Texas Symposium in New York, Gary Chapman of LA's Aerospace Corporation and Andy Ingersoll of Caltech declared, quote, "And thus our conclusion remains valid that faculae may have contributed all of Dicke and Goldenberg's excess signal in 1966, the last serious challenge to Einstein's now classical theory of gravity had turned into its confirmation." 2 years after New York, we would bring the symposium back to Dallas and then in 70 to Austin. Meanwhile, I had moved to NYU and promised to propose a program as I had for the first 2 symposia. But by August 68, I had not yet done anything about it. Al Cameron called to inform me that he was resigning from the organizing committee because it was now too late to organize a conference in December. I said I would throw it on the recently discovered pulsars. He said he knew that they were just white dwarfs. I disagreed, but he wished me luck. At the 1968 Dallas Symposium, Tommy Gold and Franco Pacini established that the pulsars were rotating neutron stars. Practically every couple of years, there was a new development in what we called relativistic astrophysics that could be discussed on short notice at a Texas symposium. It had been important to keep the meetings focused on observation and experiment, and in particular to keep crackpot theoreticians off the program. One very tenacious would-be speaker who offered his chronometric cosmology with a quadratic instead of linear redshift distance relation was a distinguished mathematician Irving Seagull from MIT. I did my best to keep him off the program. My NYU colleague Peter Lax tells me that I was not alone in trying to distance myself from Irving. Lax said the chair of the MIT Math Department said it was wrong that two of its members, Warren Ambrose and Irving Seagull, were not on speaking terms. Martin, then chair, said to Ambrose, "If Adolf Hitler were a member of this department, I would speak to him." Warren Ambrose said, "Adolf Hitler, yes. Irving Seagull, no." The 1970 symposium was again in Austin. Stephen Hawking attended. The wars about Dickey's sun and Weber's waves continued. George Gamow chaired a session, lucid but unsteady. He came with the recommendation, "He's on doctor's orders, just 1 bottle a day." I had taken the 72 symposium to New York's Americana Hotel. My student, Bill Wallace, helped to incorporate myself as a business for $10 to absorb support from IBM and the New York Academy, besides the usual suspects. We had 1,200 registered people attend, and the Academy took over now publishing the proceedings, containing a fascinating collection of astronomical discoveries, foremost Giacconi's newly revealed X-ray sky by his Uhuru satellite. Then back to Dallas in 1974, where Hawking announced black holes are white hot. And so it goes. In speaking here, I am sad and hopeful. I am sad because 2 weeks ago my friend Istvan Oshwat died. We worked together for half a century. He graced the University of Texas here and has also helped to keep the Texas Symposia alive. I am hopeful that human rights will prevail over visa problems, secret no-fly lists, and other travel restrictions, that on some future date there will be also Texas Symposia in Shanghai, St. Petersburg, or Tehran, and always in the Americas.